Okay, we're now on page. I don't know what it's on. So the first question, we've got an example here. We've got 2x minus 3 over 6 plus x plus 2 over 3 is equal to 5 over 2. Okay, this is an equation. Now if we wanted to, we could double both sides if we wanted to, but nobody wants to. We'll multiply by 6. So we'll do 6 times this, which is 2x minus 3 over 6 plus 6 bracket x plus 2 over 3 is equal to 6 times 5 over 2. It will now cancel to leave us with 2x minus 3 here. That will be a 2. There are no minuses, so it's quite straightforward. Plus 4. The 2 will cancel, which gives us 15. So we've got 2x to 2x, which is 4x. Minus 3 add 1, which is plus 1, equals 15. So 4x is equal to 14. So x is equal to 7 over 2, or 3.5. And we could feed this in up to here, and we should get that answer. Okay. Then the next one I think is fairly straightforward. So the next one we're going to have a look at is area of a triangle and parallelogram. Okay. If you had to find the area of this shape here, right, you might say there's no formula for that. Well, you're quite right, there isn't. But if you divide it up into shapes, we have a triangle here and a triangle there, and you can work out the area from that if you've got enough information. You need to know the area of a parallelogram. That's a parallelogram. What's the formula of the area of a parallelogram? Area is equal to, quick.
Base plus height over 2.
No, it isn't. Base times height. Right, if it's a triangle, you would halve it. That's the area of a parallelogram. A prism is the same shape all the way through. So a cylinder is a kind of prism because it's the same all the way through. If we have a rect thing here and we go up here, up, blah, 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 that's a prism. You might call it a rectangular prism or something. But you can have a shape like this, and then it goes like that. That would be a prism if it's the same all the way through. And the volume of these shapes is always the area of the bottom, or the cross-section, area of that, or the area of that, or the area of that. So it's area of base, or cross-section, times the height. Okay. Obviously you need to know the formula C equals 2 pi r, but I normally use C equals pi d. Okay. And you need to know form of a straight line, y equals mx plus c. Change the subject of a formula. So suppose you were told that a is equal to pi r squared, and you're asked to make r the subject. So I would do a complete swap. So it would be pi r squared equals a. No work required, just a complete swap. So r squared is equal to a over pi. So r itself is equal to the square root of a over pi. Okay. Now we're on to proportion. This is more interesting. Okay. Now there are two types of proportion. They've given an example here. Y is proportional to x. Y is proportional to x squared. And then you can have y is inversely. Inversely is 1 over x. Y is inversely proportional to 1 over x squared. An example here would be cost of petrol. The more you buy, the more you pay. Here it might be or roast potatoes as an example. Like if you've got roast potatoes and you've got to share them out, in this case here you'll note it. Well, we can make this here. Y is equal to kx. So k is equal to y divided by x. So the two quantities always divide to give the same answer. In this case, y is equal to k over x. So x, y multiply to give the same answer. Okay, so this might be roast potatoes. You're sitting down for Sunday dinner. There are 6 of you, and you've got 6 roast potatoes. So you've got 36. You've got 36 roast potatoes. 6 more people arrive. You've now got 12 people sitting down to dinner, and you're forced to share. So you each get 3 roast potatoes. All right, that's inverse proportion. The more people there are, the less roast potatoes you get. Sad news. Find exact solution to two simultaneous equations in 2 unknowns by eliminating a variable. All very technical stuff, forget it really. Or we could dissolve a simultaneous equations. You get this simple sort here. X plus 3y is equal to 27, and 2x minus 7y is equal to 8 or something like that. Okay. Now in this case you get the y is the same, all the x is the same, and then you'd add or subtract. In this case I would go for 2x in both of them, but that's one type of simultaneous equation. I'll do it. I'm going to double this one here, which gives me 2x. This will give me 6y. This will give me 54. They're the same sign. These are the same sign, so I'm going to subtract. But be careful, subtraction's a bit complicated. I'm going to do the 54 minus that, so I'm going to do the bottom one, number 2, take away number 1. So I'm going to do 2, take away 1. So the bottom is 6y. Take away the top, which is minus 7y, would equal 54 minus 8. 6y take away minus 7y will be 13y. Take this away. If I take 10 away, that will be 44, so it's 46. So y is equal to 46 over 13. Feed that into here and you would get x. Okay, and that's one type of simultaneous equation. Another type is when you have it like this: y is equal to 7x plus 3 and y is equal to 2x minus 9. Now if you wanted to, and you're a bit stupid and a bit asleep, you could go to get these x's the same. But I asked myself, why bother? We know that y is equal to this, and we know that y equals that. So those two circles are equal. I call them circles, although they're not circles, but that's what I do. So that's 2x minus 9, which makes it a very simple equation. 7x minus 2x is 5x. Take that 3 over, goes minus 12, and I'm on a roll. X is equal to minus 12 over 5, which is minus 2.4. Okay? Now, you then have to find the value of the other unknown. Another type of simultaneous equation is this: xy is equal to 24, and 3x plus y is equal to 10. I've invented these, so the answers will be nasty. For number 1, this implies that y is equal to 24 over x. We can then feed this into there, and we get 3x plus 24 over x is equal to 10. We have a fractional equation. We don't like fractional equations, so we multiply by x to get rid of that. So that will give us 3x squared plus 24 is equal to 10x. That's obviously a quadratic, so we take the 10x over. So we've got 3x squared minus 10x plus 24 is equal to 0. Now, since I've invented it, it probably doesn't work out nicely, but we might try product first of all. The product is 3 times 24, which is 72, and the sum is minus 10. So we're looking, hopefully, for two numbers which multiply to give 72, maybe 1 and 72, but obviously not, because they've got to add up to minus 10. So maybe it's minus 1 and minus 72, but obviously it isn't. Maybe it's minus 2 and minus 36, but it isn't. Maybe it's minus 4 and minus 18. I've missed out minus 3. Maybe it's minus 3 and minus 24. Since I've invented it, I've just invented it, so it probably doesn't work. So we'd have to use the completing the square. Now this has taken 510 seconds so far, so I'm going to stop. See you on the next tape. Bye.